Okay, we're going to make a function that fits these 2 points. The function has to go through keyword here minimum at 0, 2, and a maximum at 3 pi comma 6. And that's kind of a hint to what they say down here where we're going to do this in radians. All right, so just a quick reminder, when we are given the choice, when they just kind of leave it open and say sinusoidal function, you really have an option of either using the sine function or the cosine function. So I have those on here just as a reminder of the 5 anchor points before we do any transforming and fitting it to other points, to know where those are. And the main difference is cosine compared to sine starts at the top of its amplitude and then follows the pattern from there. It goes down through the midline and back up down through the midline to the minimum, and then back through the midline back to the maximum. Whereas sine just starts at the midline, goes up, and then cycles through. So in this case, if we just start out by marking kind of the points they give us, we can pick out a few key things right away. All right, so 0, 2. Now, I'm noticing that the points they've given me so far, none of them, even the minimum, has a positive y value here, right? And then the maximum certainly is higher than that. So I'm actually going to adjust my little axes. If I was using graph paper and a pencil, I would kind of set up my workspace so that it's biased towards the positive y axis, or the upper 2 quadrants. So 1, 2, 3, 4, 5, 6. Okay, so this first point here, in fact, maybe I'll use red. Maybe I'll use red for this one and just put a dot there. But then down the way, make some tick marks here. And, going from the bottom, I might look at this one, going from the bottom to the top, or from the minimum to a maximum on either of these models is not an entire cycle. It doesn't take a whole period to do that. In fact, it's only half the cycle. It's exactly half. So when they give us a minimum and a maximum, I kind of get the idea, this is only half of the function in terms of a full period. So what I think I might do here is kind of count by pi's, and I'm going to call this 3 pi. So I'm going by 1 pi, 2 pi, 3 pi, and that's when it gets to its maximum. So maybe I should change colors. I'll go make that one a purple. This will be 3 pi comma 6 is that point there. So on any of these sinusoidal patterns, when we go from minimum to maximum, we cross through the midline. And now that you've kind of plotted these out, it's pretty obvious to see the midline's got to be right in between 2 and 4. So I'm just going to grab I think I'll use a little lime green dotted line just to give my eye a visual where that midline is. And I'm going to go ahead and place some anchor points. What is exactly between 2 and 6? We know it's a height of 4, but from 0, okay, out to 3 pi, exactly halfway there is 1.5 pi. So, and I think I'll label that above here. So that would be another way of doing that, is to take the n value and just cut it in half. So 3 pi halves, okay? So there is an anchor point right there. And if you think about it, that's kind of our stepping stone, just like with the parent functions over here, to go from one anchor point to another. These were all pi halves apart from each other, weren't they? Okay, so before I decide what the function is, I'm going to get real familiar with with what the rest of the anchor points are. Okay, so let's just zoom out. If it goes from 0 to 3 pi, it gives me half of the cycle. I can kind of put the rest of these dots down here and extrapolate past what I know with the pattern. So from 0 to 3 pi gives me half of it. So from 3 pi out to 6 pi, another total 3 pi out there, I'll end up with back to where I started. So it's not telling us to graph here, so you can kind of skip the rest of this if you want to, because the real important thing is to notice where that initial anchor point is, of course, where your midline is, what the amplitude is here, and then of course we need to find the period so we can understand what the B value is. So I put down in the bottom right corner over here how we calculate the B value, because we've got to either go with this model or this model. All right, so I'm going to start filling this out, and I'm going to use the cosine. And here's why I'm going to use the cosine. Anytime I have an anchor point that's on the y-axis at either the minimum, or even if it would have been the maximum, that would have been easier. It would have lined right up. I'm going to use the cosine. So here, the way I can get away with it is to flip this anchor point down to be the lowest point is just a negative out front. Okay, so we're going to have a negative cosine function. Okay, we know the midline is at a height of 4, so that's the vertical shift. That's the D value that we either add or subtract at the end. So we add since it's positive 4. Amplitude, that's probably the next easiest thing everybody's thinking about. This thing swings a total of 2 above the midline or 2 below the midline. So -2 cosine. And now we don't have any phase shifts, so to speak. That anchor point I'm using is right on the y-axis. I don't have to shift left or right to get this point down to here. It's just a reflection. And so that's accomplished with the negative. So all we have to do in the inside layer is come up with the B value. So remember, B is 2 pi over the period. And since we were able to count out the period is 6 pi, okay, 6 pi was an entire cycle of this thing. That is 6, there we go. Okay, period is 6 pi. This will reduce real well. 2 over 6 is 1/3, and a pi over pi, those are going to reduce to just phantom ones there. So B is 1/3. That goes right here. And that is what I would put for my sinusoidal function, which is modeled going through these 2 points. I hope that helps. Let me know.